looking at these two graphs right here. Does this graph right here have the same shape as this graph? Sort of, but not really? What's missing? Okay, so does this graph match your answer from number 2? Do these match? No. It's only the top half. Right? It's only the top half. That seems weird to me. Does that seem weird to you? That I found the inverse and got this graph, and then found the inverse and got that graph? Okay. We need to fill in some blanks here. I need to make sure your vocabulary is good. Obviously 9's not today because I couldn't even remember how to say that one thing. But I'll figure it out. I'll let you know. Okay? These two graphs are inverses of each other. We'll fill this one in a second. Okay? What are the properties of inverses? Well, their graphs are... First of all, they are similar, just so you know. Okay? Maybe not the geometric definition, but maybe so. They are reflected over the line. Perfect. Y equals X. I know. I was letting you have time to get there. What's going on with their equations? Equations have the X and Y switched. Absolutely. Absolutely correct. So this graph right here, what's the equation for this graph? Perfect. You are on your game today. The shape of this, it's actually called a vertical parabola. That's absolutely why it's called a vertical parabola, because it's facing up. Would a parabola facing down also be called a vertical parabola? Yes. Okay. So what does this graph look like? Which one of those two graphs that we graphed does it look like? It's the whole one, right? That one? What's the equation of this graph? X equals y squared. And I know we haven't talked in class about things like x equals y squared, but have you seen one of these before? Where? In your project. Okay? Some of you used x equals y squareds in your project. Some of you didn't. If you didn't, that's okay. If you did, you kind of have a little step up for everyone else. Okay? What do you think this shape is called?
Horizontal.
Perfect. Okay. What is the problem with this graph? This graph is not a function. But this is not a regular sentence. Even has an exclamation point. This graph is not a function! Like that. Okay? So normally, we just graph the top half. And call it the square root function. Okay? Quick conversation. We talked a while ago in the fact that we can't always just call this a square root sign, because what do we need to call it in a more general sense? A radical, because that's the name of this. We are specifically talking about a square root function here. We're not talking about any other root, like a third root or a fifth root or anything like that. Okay? We are specifically talking about a square root function here. Fair enough? Okay? So this is the table. We've already seen this from the previous page, right? So let's go ahead and graph it. Because we need to talk specifically about its domain and range for a moment. Anybody tell me the domain of this function? Okay, time out. I need to address this real quick. 0, 1, 4, 9. That is the domain of the table. Excellent catch. We want to know the domain of the function, so of the graph. Okay? So because we had an equation, because we could connect it, it's going to be a slightly different domain than just the table, isn't it? Okay? So when we think of domain, like you guys did on your project, first of all, let me compliment you in the fact that I see you feeling a lot more confident about domain and range after the project. Whether you feel that way or not is one thing, but I have already seen a change in you feeling a little bit more confident about domain and range because of how hard you worked on it on the project. Okay? So we think, how far to the left does this go? It goes to 0. How far to the right does it go? All the way, right? So how do I write that? Absolutely. Okay? Do you remember the other way that I showed you at the very beginning of the year that you might have to write domain and range? Like this? Okay, I'm just making sure. I don't want to lose anybody. Get mad and leave if you want. I don't care. I mean, I kind of do, but stop talking. You can only use blank values for blank. Positive values. Oh my gosh, you are seriously on your game today. So you understand that. Let's make sure everybody else does. What does this mean? You can only use positive values for x. When x is greater than or equal to 0, those are positive, aren't they? Okay? And we're talking about domain, so x. Okay? What about the range? First of all, we have to start off with y. Good. Perfect. There's the other way, just so you have it. Okay? You will only get blank answers for blank. You will only get positive answers for y. Can anyone explain to me why those two are phrased differently? One of them says you can only use positive values for x. The other one says you will only get positive answers for y. It is y equals. Have you ever heard of these words before? The domain or the x's being the input and the range or the y's being the output. So if I'm putting in positive values, what am I going to get out? Positive values. Okay? Any questions? Does that make things a little clearer on some of the questions you were thinking about earlier? Let's look at this review of quadratic transformations. So we're given that equation. For the equation above, complete the table, then plot points to construct the graph. We're not going to take the time to use our calculator for this. We are too smart for that. We're going to act like we are for just a second, okay? What's negative 2 squared? 4. 4 times 2, 8 minus 2. Oh my gosh, we are too smart for it. What is negative 1 squared? 1 times 2 minus 2. 0. 0 squared. 0 times 2. 0 minus 2. Negative 2. 1 squared. 1 times 2. 2 minus 2. 0. Can anybody predict what's going to be in that box? 6, how do you know it's going to be 6? Parabolas are... I'm not leaking. I'm asking you. I'm helping you, giving you a hint. Parabolas are symmetric. Absolutely. Okay. Is it right though? 2 squared is 4. 4 times 2 is 8. 8 minus 2. Oh my gosh, it's right. 6. So plot these points. -2, +6. -1, 0, 0, -2, 1, 0, and 2, 6. They are our zeros. Good catch. This graph is a transformation of the parent graph y equals x squared. Tell how each constant in the equation changes the graph of the parent function. What effect does the -2 have on the graph?
By shifting it up or down?
It shifts it up or down. Which one is it?
Down.
Down. It is vertical, yes. Vertical shift down 2. If you're going to write shift, please remember your F. It's important. What effect does the 2 coefficient have on the graph? Wait, what's a coefficient?
The 2 in front of the x?
Like a multiplier, right? Okay, the 2 in front of the x squared.
The compression.
It's a compression or a stretch.
It's a compression.
It's a vertical stretch because it's more than 1. 2 is greater than 1, right? If it's greater than 1, it's a vertical stretch.
Okay.
But it's a vertical stretch by a factor of what? We're only doing verticals in Algebra 2. I can show you very easily how you know if it's a horizontal, but I'd rather do that later if that's okay. So what about number 5? What do you think we're going to do? Switch x and y. Okay? First of all, I'm sure you all read the directions to know that it wants you to switch x and y. Of course you did. Plot them. Plot the points. Oh, that was not good. I'm sorry. Can you pretend it's a nice, pretty parabola-ish? Is it a function? How do you know? No, it doesn't pass. Vertical line test. Or it has repeating x's. Excellent. So how are we going to find the inverse of this function? Switch x and y, right? Okay. So when I switch x and y, I get x equals, good, 2y squared minus 2. What is my goal here? To get y by itself. That's absolutely right. Okay? So what do I need to do first to get the y by itself? Not yet. Can't do that first. I have to add 2, right? Add 2. It's okay. X plus 2 equals 2y squared. Now can I take the square root? I have to divide by 2 first. Excellent. So y squared equals x plus 2 over 2. For the record, I know some of you can handle this. That's also the same thing. Can you tell that? If I divide each term by 2, I will get this. Fair enough? Okay. Now can I take the square root? We've been trying to take the square root the whole time. Is it time finally?
Yes.
Square root, square root. Y equals the whole thing. X plus 2 over 2. It's the square root of the whole thing. If I was doing it over here to this one, I'd get y equals the square root of 1/2 x plus 1. But the whole thing is in the square root. What's the notation? F -1 of x. But it's still just x plus 2 over 2, isn't it? Oh. Use a calculator to help you sketch the graph of the inverse below. Oh my gosh, you are so great today. Wouldn't it just be the top half of it? Yeah, absolutely. Does it match your answer from number 5?
No.
Nope. Why?
It's only half.
Only half. That's only the top half, in fact. Okay? Any questions? Uh-huh. Uh-huh.
How come when you divide by 2, you divide by 2?
Because you don't know the square root of it. Your homework is the back. 7, 8, and 9. Okay? Your homework is the back. 7, 8, 9. You still have some time in class. I expect you working on this because then you can ask questions as you go. Please don't put your stuff away. You know better. Any questions? Ask as you go. Okay? Ask as you go. Peace.